So today is going to be an unusual talk, and I think that some people in the room already saw it. I did in Stuttgart, and I'm going to give some continuity of what we were researching, doing some additional comments. So it's funny that we are talking about S-bombs and those kind of things. I reached this topic because we have the complexity of the volume of cases in curation that we do. Handling all the mechanics is not easy. And I'm gonna first explain why and where we are going and what are the companies and organizations who are actually paving the way. So a little background on me. Most people know me as Oscar. My second name is Andrew, or Andres, right? So a lot of people will know me as Andres as well. Old joke that we use. We have a long name in Latin America, so we can use multiple, and it makes it very useful when you need to do contributions, and you work in a company don't like it much. So previous year were that way. So my background is in telecommunications and electronics, specifically device and consumer devices. Then I moved to informatics, and then I jump into compliance. So long time. And today we're going to talk about the open source license compliance, right? There's a challenge where people understand open source compliance as simple as we're going to do a scan, and the truth is that doesn't work. And the reason is because scans show very static analysis on the risk more than understand what is the problem. When you do a scan, you're going to have different challenges, and you need to understand as well the technical implementation, the modification had done, how the software interact, what the customer interact with the software, or the user interact with the software. And also, there's a bunch of dynamic conditions that happen and flow around the case. For example, if I have a software, most likely you're going to have one license, and that license will work differently and trigger different conditions and approvals and obligation for every use case, right? You can have bucket of use case. But the complexity is not linear, and it's not just that for the use case. It's actually also understanding that every license will work differently depending on the type of project or the type of product that you're building. And also, you need to understand there is a bunch of components that have multiple licenses and multiple components. So it's not only trigger in a matrix of risk for that particular use case, but also how developers integrate that software and decide to activate different plugins and different models. This is very traditional when I see cases like FFmpeg and software like Electron, apps or Chromium and everything. They start like growing in complexity and make it more difficult to actually track. I know that a lot of people prefer to just do a scanner, but the truth is that the scanner is going to show you like the heavy lifting of what they identify, but you need to understand how it works. Also, it's additional cases like implementation. We used to worry for certain license about how you link it dynamically or statically to understand the scope of the copyleft effect, for example, how it affects your product. But today has been evolved into a way more complex cases where you need to understand what APIs are being used to understand what are the covenants specifically for the license, patents, and other obligations. Because the scope of a copyleft, for example, is going to affect differently. And not only that, we need to understand also a little of the ecosystem of how the software and the specific language we are using works, right? In some cases, for example, a Python package is mostly source code under LGPL v3 will have a reduced amount of like complication when you distribute it use in different use cases. But as soon as you change the language, the whole scenario change, and the obligation also triggered differently. So all this complexity, it keeps growing and growing and growing. When you handle over 800,000 package creations, it's getting like a nightmare. And it reached a point you need to start understanding how you can benefit from tool if you're using the right tools, but also understand the process. Because as much as you, for example, when you are using internally, you worry about your use case, but when you're building product for other people, like in SDKs, people will be affected, and most likely it's not going to be affected directly by using the SDK. The final product is going to be on different. So if you work with partners, your partner is going to be on the hook for obligations when this is going to be shipped. In tailored guidance works in certain ways, but the truth is you cannot build blueprints for products. That's getting more and more complex. and it's going to keep growing as much as the technology grow, the number of products your company grow, in other cases. Like, for example, AI. This is going to talk about a little later. So tools in general are not magic wands. There's a bunch of people who think that I'm going to buy the more expensive tool and I'm going to run it and I'm going to have everything from sure. It doesn't work that way. Because nonsense interpretation is mostly required, and there's a lot of cases where I see companies and people over-trusting tools, expecting that the tool will give me the assessment, and the truth is that doesn't happen. Tools have limitations, but also need to understand the context on how it's running against the product. What is the thing that you're trying to evaluate? And again, tools struggle with complex technical scenarios. There are some tools who will work, some other not. Also, tools work as a black box. I've been seeing cases where tool understand the license of PHP. It took them 3 years to fix that PHP peer packages were not PHP license, but it was in fact GPLv3. And that's very common happening. And some other tools suffer of the Swiss Army knife syndrome. That's mostly try to include as much of features as they can, losing some gaps. And then we have the momentum of where we do the scan, right? We are coming with a open source life cycle where you have consumption and you have, ingestion and consumption. When you do the scan, it have different risks, different buckets, and also when, what the kind of referral material you're referring, like when it happens statically or when you have dynamically, when the software is running, when you have a file that you are scanning. And this is very typical. I've seen cases of models, AI models, where people do a static analysis and they are not aware what the models is actually doing when they are being executed. And I'm going to talk about those numbers later because it's getting really, really interesting. So again, source code and binary implementation will look differently. And even when you do a static analysis with complex algorithms and other things, the truth is that metadata is simple extraction will not work all the time. You need to understand a little more deep. So with all this complexity growing, the truth is that we are not able to cover everything, right? We have to assume certain risks and we have to assume what we can deliver. And that's when we come with the agentic approach of how to do things. In this case, for example, the question is agentic a good option, right? And we need to understand the open source license compliance is dynamic. That's the reason why we need some help that can help us to scale and understand certainly. Tools agent will not understand the context, will not resolve, but it's going to help you to create the data. It's going to help you to investigate more and expand and augment your capability for understand the nuances. And for that, we need to understand what they can do and they cannot, right? They're going to do the heavy lifting, doing the research, doing executing tools, and that's the thing that we're going to do, mostly like an OSPO on demand, if you want to see. We can use the information generated to build a conclusion or make a recommendation, but it will not replace open source engineers because at the end of the day, someone needs to take the decision. So before jumping into agentic and the solution I'm going to show live, I want to talk a little about the difference, right? My hope is everyone understands the difference between an LLM and an agent. Basically, the LLM provide knowledge, is the brain, understand general language, do the translation and summarize and manage the data, but it doesn't act, doesn't execute tooling. The agent, another way, I execute tooling, achieve goals, and it is able to learn and adapt because it have memory together with LLM. You have different type of agentic. You have the reflex, you have the goal-based, utility-based. I'm not going to go deep there because the presentation is available. You can take a look on different things, and the multi-agent system. So how we solve the problem for handling SBOM with agents, right? And the answer is we need to think about how they will be the ideal scenario. In an ideal scenario, you're going to have an SBOM, you have your policies, the SBOM and the information the SBOM go through your policies, you have the different buckets and approvals, you have cases that are rejected, and you're going to generate, based on that, your tables and your notices. The truth is that doesn't work that way because SBOMs are transfer protocol. It doesn't mean that the information and the transfer protocol and the file will be correct. It will be lack in some case of quality. So you need to recreate some of the information based on the inference that you can do. So in order to do that in a practical way, thinking that the SBOM is what we're going to assess, we need the other challenges like the different file formats. There is a bunch of discussion around SPDX, CycloneDX, and Kisses, bombs, and a bunch of others. The truth is like none of the parsers really work well, right? If you try to create your own, it also is going to be challenging. If you try to create any other Python library, it will not work very well. So you're going to have this situation where when you go into practice to try to scale, that you're going to need some help. And agents are really good handling those cases. And commercial tools don't produce compatible SBOMs. I'm seeing some commercial tools that incorporate private like notations in the IDs, so are not very compatible with open source tooling. And you're going to have like the data, a bunch of no assertion, no hashes, manually edited hash strings, and a bunch of things that you really need to be able to assess to see if the SBOM quality is correct. So for this example, we're going to use 3 agents. We use the Reflex agent, an utility agent, and a goals-based agent. Each agent will be doing different things. I'm going to show you how SBOM Python works, like how we do the assessment. This is just an example of the case. There are more complex ones. The first one, the Reflex agents will take the SBOM and it's going to extract the ports, the package IDs. The second is going to connect a bunch of organizations who offer the APIs to provide additional data and help you to create and enrich the data from the SBOM, so you don't need to really trust what was incorrectly declared for some commercial tools. And then you're going to have the agentic that will basically do the open source engineer role, which is going to take the information and is going to produce your artifacts based on a role, context, expectation. The more important thing for any agent is always define well the role, the context, and the expectation, right? Because it's what the LLM will understand. Now, of course, the model is important. I'm seeing some models that are teeny, that don't do really well. Other models are really good. Like, for example, I know Granite, Llama, teeny Llama doesn't work very well for executional tooling. So you need to test and see how those works. So what we need when you want to implement something like this, an automated open source compliance process using SBOM, a place where your agents will live, like a workflow, an LM to support operations, of course, an input-output for the workflow, how you're going to communicate, tools to enrich the data, like the APIs that are provided by the open source communities, and of course the SBOM and coffee. So I want to show live how this works. I use a software that is called NNA, that is not open source, but is free to use. You can use any other. This is an example how the workflow works. Basically, we're going to use an input-output, an email. Everyone knows how to use Gmail. You can use whatever, right? This is just an example. And the email will arrive. It's going to trigger the process. It's going to filter out. It's going to identify you have a JSON. It's going to extract the file. It's going to use a smart parser, so I don't need to deal with CycloneDX or SBOM or, SPDX or whatever format, or some format that are broken. It's going to extract the information I need. Then it's going to go into my tooling agent, who is going to connect to a bunch of places. I can incorporate new tooling just in here. And then the information is going to be collected. Once ready, it's going to be passed to the other agent, who is going to do the assessment. It's going to create my notices, and it's going to reply back. Okay? Let's see if it works. Hope so. If not, Chain is going to fire me. Okay, so get an OSPO. Parse the SBOM. We're going to attach an SBOM, and we're going to send it. You can use whatever software, okay? I'm just using this because I'm lazy and I don't want to recreate it. And I want to show something at the end that's going to be fun. So here's the Gmail. Let's see if it's arrived. Not yet. We hope that it arrives soon. This is a demo live, so of course the communication is going to be more slow than usual. Get and OSPO, yes. And the email's there, perfect. So now, this is usually running in the background all the time, right? I stop it just because I'm gonna show you step by step what the agents are doing. So it arrives, and I'm gonna just execute the test. Boom. So, let's see. I think I said lose the communication. Let me refresh this. There. So executed all the pipeline to validate the file and the attachment. It went to the parser. Now it go into the other agent that is gonna start collecting information. So this is very cool because it's doing everything that I should doing, right, Henry? I used to be doing it by manually. I'm not gonna do it anymore. So that's super cool. And it's gonna execute the API calls to clear the find, and search for information, provenance, notices, and all this stuff. It's also checking vulnerable code, which is getting all this fun information about vulnerabilities, provenance, and scan results. You can also connect, for example, scancode.ai to make a system call and do scans on demand. You can connect, I don't know, any tool that you want. And this is just taking a few minutes to parse the SBOM. I'm using a small model, so it's gonna be taking extra time for handling the context. It's limited memory. You can use any model that support the window of tokenizing data that you're gonna handle. In this case, I'm using the smaller turbo from OpenAI, but I've been testing it with Gemini. I've been testing with a few in Amazon Bedrock, and Cloud. So you can use any model. I have a few on my system. Okay, let's see. It's taking time, but it's executing. While that happened, I'm gonna show you something that we are cooking. Well, I'm cooking. This is an open source agentic platform, so you can create your own agentic at home, in your computer, fully offline, running totally on-prem using Olama, okay? So in this case, I'm handling 2 providers. I can do Olama, I can use OpenAI. I can just choose whatever model I want. I can install any model, so you can do A/B testing to see if that behave better. I can create workflows. For example, this workflow allows you to do the same thing that I'm doing on the other side, but it's gonna be more complex, right? And I like it because it's no code kind of implementation. This requires a little more like JSON understanding. And this is a parole assessment. And then I have my agents who I can provide like the context of the different roles and given access to certain tools. And basically it's gonna run, it's gonna do the same case. Oh, I think this was an issue, but it was clear defined, but it continued and it sent the email. So let's see what it sends. Here has the SBOM. So here's the summary. Provided the licenses, it's just extracted licenses and then use the APIs to get the license, and also got the scorecard assessment, new vulnerability for this code, and it produced a tentative legal notices, which can be enriched with the full license information. This is just a very dummy example, okay? We have been working on other more complex examples. That just handle a bunch of other cases like this. But basically, we're gonna move everything into this tool so we can offer a fully integrated open source solution that you can run agents into a computer. You will require GPU anywhere, right? Because you're gonna be running the model, of course. But you can use it and deploy it in a simple Docker. So let's go back to the presentation. So, what we know, you need data feeds of knowledge. And for that, the agent will do the work, but they need to have that information. They need to have some references. You need to have the data feed providers. And that will be a dynamic shift on how we traditionally do compliance. We're gonna move into, let's do the scan, a bunch of things, into get data from other organizations. And again, AI won't replace open source compliance engineers because there is still some context that is needed, but it's going to help us to scale. Some organizations who are paving the way, Scano says they have custom KDB, you can use it. They have some limitations, but still you can get information from there. They have launched a data set with geo-provenance, so you can do export control over the software in the open source cases as well that you use. Vulnerable code, Adam is here if you have any question for the organization. It gives you vulnerability database. It gives you also license information and scanning as a service that you can implement. Software heritage, we are looking to use it for tarball storage or handle the tarball for copyleft and open source compliance cases. You can have information functionality and clear define and dev stat gonna give you a bunch of information. If you wanna download all these artifacts and presentations, the QR code is there. Chain can share the information as well. Now, before jumping into questions, I have a question for the audience. How many of here use AI models in their organizations? Perfect. How many of you actually do open source compliance on those models, like verifying licenses information? Okay. How many of you actually verify provenance of the model in the data? Okay. How many of you actually do scanning on the pickle to look on problematic security issues? How many of you have detected or seen that there's a bunch of cases where they have remote shells being called on models executed? Okay, Dave, you are way, way behind what I expected. Congrats. So it's funny, we were doing some research. From 160,000 models, only 35% have a license. 700 models have been redistributed on GitHub inside other packages and under permissive licenses, which are not like permissive licenses. Only 14% have dataset declarers of provenance. Only 18% have declared bias. And for security cases, it's fun. What we've been seeing is in 2020, there was a supply chain issue. So open SBOMs for AI make total sense for supply chain ingestion. It was a supply chain issue where people modify, it create an application called torch return, and that allowed to have remote attack of system running models. In 2023, there was a demonstration that you can actually, with Poison GPT, some researchers did some backdoors in the systems using models that were executed by someone else. And in 2024, already JFrog discovered over 100 models doing these security attacks. And also in that same year, Yellow V8 was ingested with crypto miner code to run in the model. So while people was running the model, they were actually crypto, meaning crypto for the attacker, and using the same GPU, which was fun, right? And in 2025, this year, there was like a bunch of obfuscated pickle files with backdoor that were discovered. And the fun part is we are not doing any compliance mostly on models. We are just talking about it, just starting. So it's a subject that we need to scale. I found this while I was working on these different models and A/B testing. Oh, and this is only static analysis. No, I really had done dynamic analysis on when the model is running. So, a lot of fun. Cheng, question.
You mentioned the discovery of some models phoning home.
Yeah.
Yeah. That's a really interesting one. I hadn't encountered this until you raised it. And I just wondered if you could say one or two things about what that phoning home
So there's two functionality that were discovered, phoning home and reverse shells on the models. So the phoning home was actually reporting usage. It's not sure, not clear it was like something good or bad. They were reporting usage in the architecture where the model was running. And the infection was not in the 1 and 0 of the model, it was mostly on the pickle where binary blobs were hidden. Yeah, I think we should start working on a registry or a publication around it.
What was it? More than one model?
Yeah.
Yeah. Oh, wow. Interesting.
Good for us was not one of the most used, but the problem is the current ACA tools don't really parse pickle or serialized data, right? So this was mostly like, hey, this run a weird behavior, but there's no really mechanism to go in to see the models. We have found cases where, like, for example, Hugging Face had not been able to scan, JFrog detected later. There's other cases where have been flying, and for companies who actually offer services for hosting the models or deploying models for customers is getting concerned because there's certain supply chains role and work that it should be doing, and we are just starting the conversation.
Wow. Okay, a big hand for Oscar, and then, of course, if you have a question. Oop. We have a question from Kubota-san. I believe Sony's been doing a lot in AIs.
Sorry. Thank you for the great
Sure.
presentation. And I have one question. As you said, static analysis and dynamic analysis will make different results. And also from the license compliance, it's very crucial to the build timing and deploy timing. And on the other hand, security perspective, it's very important, runtime dependency. So there are many types of SBOM, such as build SBOM or runtime SBOM. Which type of SBOM should we use or check?
That's a good question. Like, if we try to generate a risk assessment for an open source, right? When that risk assessment need to happen? And the answer will be depend on the software development life cycle of your organization. So we have some ingestion pipeline, for example. I'm gonna switch back in where the Amazon had. So it's like we have some ingestion verification. We go and do certain assessment based on assumptions on how it's gonna run. We have other that go into when the software is incorporated in products, right? And then we have another different that when it go out. What we have not been explored as an open source, but mostly from security we have done it, is dynamic on open source analysis when the software is actually running. For example, if you have an application, when you launch it into a device, you are able to capture how the application is behaving, analyze it. And this is super important because the same thing that was talking about models, there's a bunch of, for example, Python packages who incorporate the Python models, and we are assuming that the license is Apache and there is no risk. But there is a binary inside that is shipped with the wheel of the Python, right? And I was not aware of how wide this case was, and that being like executed with the Python package and not being inspected. There is no way that SCA tool, no product SCA has been inspected those pickle models because you need to load it. So it need to happen assessment of the risk depending on the different risk vector that come from your use case.
Thank you very much.
Thank you.
All right, do we have any other questions? Dave?
Thanks, Oscar. Actually, two questions. One is, the icon that you use for your agents, I don't know why, to me it feels a little bit sinister.
I made it that way. Yeah, I created. Yeah.
It's nice. And then the second one is, in your experience, as you've been using sort of this agentic workflow, what have you seen relative to how it compares to the error rate for a human, open source engineer, like false positives, false negatives?
So agents are more structured to work, are better to ask them to produce an auditory. And one of the things that incorporate that is really good is memory. So if I handle 100 cases per day, right, I'm gonna start losing the context of what I proved before, and getting into a system that allow me to do it is gonna be very difficult. Agents can store that memory, it's gonna incorporate. That helps them to work, but how accurate the assessment is, like the final assessment of risk and everything, will depend on the type of model that you run. Because I'm keep seeing cases like I have a small computer, so I've been using a simple agent with a simple model in my computer to do some assessments, and the radio goes crazy, right? It does hallucination and a bunch of other things. But if I do a hosting one, like for example in Amazon Bedrock, that allow me to do a bunch of other things, the accuracy is better. Now, remember, the model has execute once, another, but it doesn't have the context of all the history, so you need to provide it a way to get memory. You need to provide a way that will get better accuracy. I don't think that this is going to replace open source engineers, compliance engineer, but it's going to help us to scale, right? That's the target. Like when you do a bunch of cases, you do 1,000 cases, you need to have a way to scale.
Yeah, so what I'm hearing is that the open source engineer runs a sort of a fleet of agents and is the clearinghouse for the final go, no
Right.
go.
So in Mary Alomi, it's going to be like the co-pilot of of the open source engineer.
Thank you.
That's awesome. And I believe that accidentally, just because I made it up now, Oscar's volunteered to make all the OpenChain agents.
I can do the examples and the templates. I'm going to offer the templates. I'm not going to do it for other people, but I'm going to do the...
This is the first step to making me unemployed.
I'm going to do a virtual chain. Well, we can do a personal assistant. That's been working. I've been using a personal assistant for like a year and a half now. So,
looking forward to it. All right, is there any other question? All right, Oscar, thank you very much indeed. Another hand. This is a field where we're, yeah.